This is Jonathan Blow's interview on why he does or does not like Rust, and apparently chat is a bunch of degenerates.
We need to work on is we need to make software work better generally. We need to make it more so that when you write a program, you know that it's correct, right? To a greater degree than today, right? And it would be helpful to do that in ways that are not the ones that have been well trodden, because we kind of have seen those ways before. So for example, a garbage collect, like a Lisp variant or something, right? Is actually, it's safe in certain ways, but it's actually very unsafe in other ways, because like Lisps, for example, were not traditionally statically type checked. And who realized that that's actually important, right?
Okay. I like this take, which is that today's languages and the way we've done things aren't necessarily the best way to do things, right? We can all agree that we've all had pretty crappy experiences with programming. We've all had really long debugging sessions because of the reliability of what we've done. So I'm totally on board with that. I agree. TypeScript is a terrible thing.
And so, Rust, I think, has a good set of ingredients there. The problem that I have with it is when I'm working on really hard stuff, I don't exactly know what I'm doing for a long time.
Right.
Yes. And so if the cost of experimentation is driven too high, it actually impairs my ability to get work done. Right.
I like that. I like that take, which is totally true, which is that no matter what, if you can't iterate quickly, if you don't know what you're doing, I've come more onto that camp. Wow. I've come a lot more into that camp, which is if you don't know what you're doing at all and it's like an exploratory phase, I can find Rust annoying when it's not dealing with, like, say, strings. Like if I'm doing string processing and I'm just kind of like trying to print out some stuff and I'm just doing something weird, usually I'm just doing that in awk or grep or something different, FBI open up or JQ. But if for whatever reason, I have to go and do something, I kind of compete on which one's faster. Is just JavaScript or Rust? Which one's faster? I don't know. I'm not good enough at OCaml to really be able to run with that one yet, but I feel like as of right now, they're about the same thing. Like if I can't use CLI tools, those two are about the same thing. But once I go beyond something simple, Rust is great when I know what I want to do, right? When I already have the idea in my head and it's a very self-contained program. Like I can imagine writing out a CSV parser is a lot. It makes a lot of sense because the problem, the domain is a very, very understood. Well, shall I say understood? That's a very funny phrase, but the domain is in some sense well understood. There's a set of rules that must be applied, and you just got to apply those rules in a linear fashion, and boom, you're good to go. So to me, that seems like such a W, right? That seems like such an easy win. It's well trodden. It's at least mostly understood. So a place with Rust and that just seems like such a W. Whereas if I don't know what I want, like let's just say you have a server that has a bunch of data, MongoDB, you don't even know what's in it. This literally happened to me. You don't know what's in it. It's a MongoDB, and now you have to go and explore and try to figure out how to pull some statistics out of it, right? Like you don't even know what's in the thing. So, and for me, there was 100 types or 150 individual types. So I built a program. You can still find it to this day, undefined, right? All it does is it takes in a config file and a stream of objects. And this stream of objects will literally turn it into a bunch of TypeScript definitions. And so it's kind of like clever. And that was the way I explored a data source that I had no idea what's in it. There's no type definitions. And it was all just like some Mongo nonsense. And so this was my way of solving that issue. And to me, this was like a great example where Rust would have just not been good. This just simply wouldn't have been a great Rust experience. Whereas to understand the database was just much better in TypeScript. I know, totally sucks, but it just is what it is. I wrote something like this in Bash, junior dev moment. Yikes. It looks like a lost opportunity to use Rust to me. All right, let's hear what he has to say.
Yeah, I think that's fair.
So my approach that we're doing in the language I'm working on is different. It's like you have very, very, very extensive metaprogramming facilities, and you can use those to build your own correctness checking, right, for your program that you traditionally would have needed to make like a compiler extension to do, which is like, that's pretty far away from what people do day to day, and they just don't end up doing it, even if they could have, right? And so what happens is your metaprogram gets information that normally would only be internal to the compiler. Like you get like a message loop while you're compiling, and it's like, oh, this declaration just compiled. It's a procedure. You get the full type. Like, here's the types of the arguments. Here's the types of the return value. Here's the, this identifier maps to this other thing. And so you could start having house rules that, okay. So an example is.
So I have kind of the compile time. Like I have compile time logic that can enforce different kind of constraints.
Yes. And you can decide what that is later. So a video game example, because, this is all motivated by
I would love to see an example of that, because I'm trying to wrap my head around what exactly does that mean. I think I have some set of ideas of what he's trying to say, but there's something that seems really amazing about the idea of being able to define some basic safety logic yourself while having an overall kind of loosey-goosey platform for exploration. So that way you can still move fast, but once you have moved fast enough, you can then set more safety measures in stone by like enabling doing things. I'd have to understand what this means. Comp time zig, I assume it's different than comp time zig. I love comp time is my favorite feature. I really wish they wouldn't have had that. I really wish the Rust Foundation wouldn't have had that whole debacle with Shepard's Oasis, where he was doing the whole comp time exploration in Rust, because I think comp time is vastly superior to macros. Macros are incredibly difficult to understand. Parsing through and working through the syn crate and understanding all these little things and trying to build up this syntax and all that just feels awful. Whereas comp time, you understand it inherently. It's like cooler generics is how I think of comp time. In fact, comp time to me seems like a more reasonable approach to generics than generics have ever been, because generics feel like a runtime thing, right? Even though it's technically like it's not a runtime thing, it feels like a runtime thing. Whereas comp time, it does not feel that way. Oh, by the way, when someone says Rust macros are great, I totally am on your team. They are great to use. They are horrifying to write if you're doing proc macros. Declarative no, wait, hold on. Which one? Proc macros are the ones where you have to do the whole working through the syntax, whereas declarative macros are the ones where you get to just like kind of write basic code that almost looks like it. But either way, you know what I'd rather do? I'd rather just write Rust code that's executed at compile time that generates code, right? That's what makes comp time so incredible in Zig. If you know Zig, you know comp time. It's that simple. Macros can be a huge pain in the ass to debug. Exactly. Comp time, again, incredible. But I will agree, macros are what's enabled lepto syntax, and that's also incredible. The fact that you don't have to have a transpiler, but to be able to have JSX in Rust, amazing. So that's why I don't say that I love macros. I love using macros. I hate creating macros. Two very different things. Whereas with comp time, I love using comp time because you don't even really realize you're using it. You're just passing types into something, and then boom, out comes something. But creating comp time, just as easy, right? You're just like, oh yeah, I'm doing this. Okay, here's the value T. We're just using T all around here. It's awesome. Does a comp time generate code to use at runtime? Yes, exactly. That's what it does. Think of it like it's extremely simple. If you've never seen it, here, we'll do a quick detour. Zig comp time example. Let's see if we just have a quick version. Okay, let's see if we can see a quick version. Okay, comp time. So here we go. Let's see if we can, is this a good one? Well, this is kind of interesting. Must be all uppercase. Oh, interesting. So this is like a insensitive equals, compare two strings. Okay, where's a good one for like doing, I want to see one that's like using, not that kind of comp time, just a simple one to build like a linked list. Here, a linked list. I know I actually have one. The Primogen, here. GitHub, Zig. There we go. I was working through some Zig stuff, rewriting Rust. I get it. Here, there we go. I'll do this right here. I think I have a linked list or a stack. There you go. A stack that takes in a type. A list node is just a struct that has type T and a reference to, an optional reference to the next thing. Then all I have to do is just start creating things, right? So when I push in one stuff, I create a node. I set the value to a value. Value is just t. Boom. Set that. And so it looks, do you see this? It looks just like, I mean, this just looks like generic programming, right? But all of this is executed at runtime, or all of this is executed at compile time. And so there's only one piece of code here, which is creates a version of this code where all the t's, you could just imagine every t in here is just simply replaced with I32. That's all it's done. I've only created one version of the program, or one version of that code, and that's it. So at compile time, that's what's compiled in. That's it. Super cool, right? Like, to me, this makes a lot of sense. This feels really, really good. Like, I totally get that. Yeah, and so they call it comp time. So I'm writing just Zig code. I'm not writing anything else, which I think is probably the coolest feature of Zig is this. If you haven't done it, it's really cool. And that's why I always this is why I always recommend people take a little bit of time and explore different languages, because you can see things in different ways, right? It just feels different, right? And sure, this is kind of like effectively the same thing as one could call this is no different than generic programming. Pretty much, I agree with that. In general, I agree with the sentiment, but it's incredible to see another perspective. All right, let's keep on going. I see Teach in there, by the way. Teach streams on Twitch TV. Did you know that?
The reality that I come from, right?
Yeah.
So we have these game engines, and an object in a game world, we don't use the word object because that got commandeered by object-oriented,
really did
right?
commandeered and slaughtered.
Yeah.
It's
So we call them entities, right?
thing. Right,
Even
there
though
we go.
somebody
Yeah,
else,
let's
right?
see.
So like my coffee cup is like an entity, right? And so entities have data associated with them and so forth. And you might
Right.
have different kinds of entities, like a person. You probably want a lot of different things to happen for a person than like, a soccer ball, right? Those are very different.
By the way, he's about to talk about ECS, right? Entity component system stuff. I've always wanted to really understand entity component system stuff because I feel like it's the ultimate a composition over inheritance business, but I've never really like built it out myself. I've always wanted to do that. I really, 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 really want to try it out. You know what I mean?
And so, we tend to make those different types of entities, and somehow they end up having different behavior and so forth. But
I don't want to work with it. I want to build it. I want to feel it, right? Like, I think I understand how to work with it, but I want to feel it. You know what I mean?
the way people have different ways of representing this, of course, but the way that I tend to do it is like a very, very shallow inheritance thing where there's like, there's a base that's like entity and it's got all the things that are common to everybody. And then like one level subclassing maybe, right? Other people do that a different way, but I think the way I do it is probably among the most common, right?
And are you inheriting the interface or implementation or both?
Well, it's not really about interface and implementation is the thing. It's just like, look, there's the data and do what you want with it. Like there's not getters and setters and whatever, right?
Okay, so I'm a little bit lost on where I really actually want to keep looking at this, but I'm a little bit lost on what it has to do with Rust. Okay, so at 145 it goes back to Rust. Okay, let's keep on going because we're almost to 145. I'm just interested in what he has to say.
Usually,
right? Okay.
I don't find those to actually solve
entity component system
problems.
is what ECS stands for.
So usually an entity will have an ID, like it's got some handle that you use to look it up. It's probably an integer or functionally an integer. Maybe it's a couple fields packed into a thing, right? And so because there's a coordination problem, you have a lot of things moving around in a game and like something gets destroyed, right? You blow it up or it gets paged out to another area of the world that you're not simulating anymore or something. And you have to work within a limited amount of memory. So you have to destroy these things.
He just said the word limited amount of memory. I don't think that's not a real thing. I don't know if you, sorry for everyone that's getting ads right now. $5 a month. Pretty good music. Thank you for $5 a month. But it's very, very funny that, talking about memory because this, largely everyone in the audience here is a web programmer. And in web programming, when was the last time you thought about memory? Honestly, your little list contains an insane amount of memory for what it's doing. A list of 3 integers is just vastly oversized in comparison to what you actually get.
But the nature of a game is all these things want to coordinate with each other all the time,
exactly.
right? And so if you just naively delete something, then some other entity that's trying to follow that thing is now following an initialized memory or something, right? And so what do you do? Well,
I've been meaning to release my CSV parser or my CSV generator that can take data from a lot of async sources and it builds it up in the smallest representation on a server. And so this is something because I struggled building building things in JavaScript because everything I'm doing has millions of events and I always end up crashing my server. So I'd actually use an array buffer, and I would create an in-memory table for every position and use that as a way to store a bunch of data in a bunch of these columns. And so it's been really, really awesome to do that. And I haven't dealt with strings yet. Effectively, I'm just creating like flat buffers inside of memory. And yeah, it'd be kind of fun to open source that one and kind of finish it off with strings as well. Or like us, because I only have integers, but you kind of need strings as well. So that way you can have a complex type. It'd be pretty fun to do.
Often you'll refer to things with a handle.
Yeah.
Modern C++ people, I'm putting air quotes as I say that because I think it's a silly phrase, but those people would say like you should use some weird kind of smart pointer for that.
Oh.
Smart pointer, let's go. Okay, hey, just to be fair, smart pointers are incredible in some sense. Okay, if you're working in a large application that's not a video game, smart pointer can save you a lot of just headaches. I use smart pointers like wild when I'm building apps, right? You got to. I mean, the fact that you live a life where you just don't even know the life cycle of something pointing to memory just sucks. Whereas at least with like a unique or a shared, they're great. They're great. But I do agree. If you're not in that world, you got to go all in on pointers and do them well.
That's not actually what you want to do, because you want to have like very clear and authoritative control over what is the memory for this thing, when is it live, when is it not live, exactly what happens at exactly that moment, right? Which smart pointers are more about like kind of hiding things and magically stuff happens later when I don't exactly know, right? It's the wrong thing. So anyway, so
I agree. There's also atomic locks on shared pointers, right? Or there's not atomic locks. There's like atomic counters on it too. So I mean, you could be getting huge performance penalties by using shared pointers if you need to pass it all around. So I mean, I'm on team. You got to control what you got to control.
You have some integer ID that you use, and you say, "Hey, give me the pointer to the entity that corresponds to this ID that I like. Say I'm following this entity, so I get back that pointer." Or it says, "Oh, it doesn't exist," and because there's a specific time at which this happens, you're gonna handle the non-existing case because it's obvious, right?
Right.
And then it's like, okay, I'm gonna start looking at all this data, which might be quite a lot of data. You know, I might need to use it a lot. So I take the pointer for a while and do stuff with it. Now, we have a safety problem, right? Because like, okay.
When are you done with this memory?
Yeah.
Right.
And so in games, the way that's traditionally handled is there's a very natural barrier, which is the end of the frame, right? So we do a bunch of stuff over and over 60 times per second or 200 times per second, whatever, right? And at the end of that frame, we pretty much know that
it's all garbage now.
Well, we're not really hanging on to anything, right?
Yeah, exactly.
And so it's a very clean cut, let's say, right? So, well, it's a very reasonable thing to say it's fine to do that stuff as long as you don't hold an entity pointer across a frame boundary, right?
Yeah.
Now, that's not a very generalizable rule, because what's an entity pointer versus a pointer to something else? Your compiler doesn't know that, right? But you know that.
Right.
And so when the new guy shows up, or the summer intern shows up and writes some code where he puts that entity pointer into a data structure that
actually is surviving across
like
the frame.
Some hash table that's sitting around, right? That's going to be a problem, right? And that's a very practical, real kind of problem. It's not an
They said there's going to be more Rust talk. I mean, he's describing a bunch of things that are extremely similar to Rust. Like I can totally understand a lot of these things that is happening right here. You know, like one thing I really love about is that the frame that he's talking about, you can do so many cool optimizations if you control memory and you know your life cycles. Whereas Rust, you're right, Rust does not solve that problem. Rust, by its very nature, doesn't solve that problem. And if it attempts to solve that problem, it solves it in a really kind of crappy way to solve it. Whereas I understand why people like C++ for this exact reason, is because you can really do something simple with it. And, you know, you can do these really beautiful arena allocators and just like, you can effectively free in a single call or just reuse right afterwards. It's really cool. I really do like everything that he has to say about it. And I know he's not directly saying I don't like Rust or critiquing Rust in general. He's giving really great points about how things are very difficult in the Rust world versus this. He got drama a couple years before this for dissing a Rust conference talk about entity component system. Yeah, I mean, you're allowed to do that. Sorry, Rust entity component system bevy. But you're allowed to totally diss on things, especially it sounds like he doesn't really use ECS. He kind of uses ECS. He has some sort of mix of what it sounds like ECS because you have this whole ID lookup, but then it also sounds like he has some sort of inheritance thing going on as well. I don't know. Sounds kind of interesting. I don't really get it. I'm not a game programmer, so I don't understand things at more than a very surface boxes and arrow understanding. But I really like what he has to say. I know Jonathan Blow is a very contrarian individual, but I think that you should always take time to listen to contrarians, even if you don't agree with anything they're saying. Like, even though he's giving a completely different perspective on where Rust falls short, and you may have never thought of that or understood his perspective without taking this time. And I really really like this perspective. I'd actually like to listen to this whole thing. I'll link this whole thing. I'll probably go listen to it myself on my own time. But this was really good. I don't know. But by the way, I don't agree with everything he has to say. I think he has some pretty messed up opinions. Like, his opinion about open source is identical to closed source, right? It's no different. Like, if you think that somehow open source is bad and closed source is good, stupid, right? Because closed source suffers from the identical problem as open source, except for open source people, I would argue, are motivated in a different way, which may make more artisanal software. I didn't like that take. I did not like that take. I want to listen to the whole thing. I'll leave the link in the description. Go check it all out. This is amazing. I'd love to hear more on this now that Jai is out there. Me and him have talked, by the way. I'm not going to be using it, at least right now. He doesn't want it into some large ecosystem. But I think as he's going and as he's releasing stuff, I will probably end up shooting him a couple messages, and we will get something really good going where when he releases something public, I can get something out there as soon as possible so people can go check it out. Blow on the stream, surely. I don't think Blow would want to be on the stream. I don't think he's that kind of guy. I don't know. I've never really talked to him, other than a couple email exchanges. Seems like a good guy. I mean, he seems like a nice guy, honestly. He just seems like any person who's an expert in his field is that when you've seen so much stuff, it's really hard to remember what the thought process is that you had 20 years ago. And so I can totally get why, he's a bit tougher on the people, right? Like, I do understand that way of life. So I don't want to be too hard on the guy for something like that, but it ain't me. The name is the Primogen.